Hi everybody, welcome back. This is Unit 2, Lesson 5, and we'll give this another try. This is the video that you were supposed to watch for the weekend. However, it did not get posted for some reason on Edmodo. So I'm recording it again. Maybe there was a problem with the format or something. So anyway, we are in section 8 here of our notes where we're talking about our modern model of the atom, which is known as the electron cloud or the wave mechanical model of the atom. Okay, and this is our current model of the atom. It's what we currently believe. Okay, so what we really believe is, again, what we know about the atom has come from the work of many scientists over a long period of time. Through the work of Rutherford, we know that atoms have a nucleus. That nucleus contains two particles, protons and neutrons. The protons are positive and the neutrons do not have a charge. And it is super dense. I told many of you that if the nucleus of an atom were the size of a pea, as in the vegetable, it would weigh 250 million tons. So it contains nearly all of the atom's mass, and it is always positively charged because, again, it contains protons and neutrons. Protons are positive, neutrons don't have a charge. And then what we know is that we do not know that electrons orbit the nucleus in neat planetary models. If you remember the Bohr model of the atom, maybe you call it the Jimmy Neutron model of the atom, he stated that electrons orbit the nucleus in specific pathways known as orbitals, right? And this electron would travel in this orbital. And what we know now is that we can't possibly know that. So he proposed that that was a model, but we know now that we can't really know it because anything that we would do to know an electron is there and present changes its pathway. So we know that they're there, but we don't know how they move. We don't know the path at which they move. So we can give you a region where they are found, but we don't know how they're traveling. Okay, and we do find most electrons are close to the nucleus. So really what we've done is actually taken a step back from being as specific as what Bohr said, and said instead of an orbital being defined as this specific pathway that an electron follows, we call it a region. It's an area near the nucleus where there's a good chance of finding an electron. So what we know now, the big difference, is that energy levels are not neat planet-like orbits around the nucleus. Energy levels are regions or areas around the nucleus where there's simply a good chance of finding an electron, where electrons are most likely to be found. But it is not a specific path. That's very important. Okay? So these regions where there's a good chance of finding an electron are known as orbitals. So it's kind of more like the Rutherford model. It's more like the nuclear model rather than the planetary model. That we know there's a nucleus, we know it contains pluses and minuses, and we know the electrons are found somewhere outside the nucleus. But we're really unsure how they travel, because like I said, anything we do to know that an electron is here, right, will change the way it's moving. It throws it off course. So the electron might be here, but it might be moving something like this. We don't really know. We have no idea how they travel. And so that is, I guess, the progress of science is that we now know that we don't know how they move. Whereas back in Bohr's day, he had thought they move in these specific pathways. We're not sure of that. So we did take a step back from what we originally, or what was originally proposed. That's it for tonight, everybody. Have a great night, and we'll see you tomorrow. Bye-bye.